In September 1859, telegraph operators across 2 continents watched their machines catch fire while the wires carried a current nobody had sent. Some pulled the batteries out. The messages kept flowing anyway. The power was coming from the sky. Richard Carrington was 33, an English brewer's son who had built himself one of the finest private observatories in the world. His obsession was the sun. Every clear morning he projected its image onto a screen and drew the sunspots, day after day. On the 1st of September, just before noon, he was tracing an enormous sunspot group when the paper suddenly flooded with light. 2 points of blinding white fire ignited above the spots, so bright he thought sunlight had punched a hole in his instrument. It hadn't. He was watching the largest solar flare ever recorded, in the first moment any human had ever seen one. He ran to find a witness. Within 5 minutes the light had collapsed to 2 fading points, then vanished entirely. Across London, an amateur astronomer named Richard Hodgson saw the same flash. Their reports would be published side by side. And at Kew Observatory, at that exact moment, the needles of the magnetic instruments twitched, as if the Earth itself had flinched. Carrington had no way to know what he had just watched leave the sun, or that it was aimed at him. The distance from the sun to the Earth is 93 million miles. The thing crossing it would arrive in 17 hours. A typical solar eruption takes days to reach the Earth. This one covered the distance in 17.6 hours. It arrived on the night of September 1st, and the night side of the planet lit up like a stage. Auroras are polar things. They belong to Norway, to Alaska, to the empty latitudes near the magnetic poles. That night they were seen in Cuba, in Colombia, in Hawaii, southern Japan, and Queensland, Australia. In Baltimore, the light was reported brighter than the full moon. People stood in the streets reading newspapers at 1 in the morning. In the Rocky Mountains, gold miners woke, saw the glowing sky, and started cooking breakfast, convinced it was dawn. An Australian observer described colours deepening into a rich purple, washing overhead in waves, as if the atmosphere itself was burning. Some people thought their city was on fire. Some thought it was the end of the world. Nobody thought about wires. Because the strangest thing that happened that night wasn't in the sky at all. It was happening inside the newest machine on Earth. In 1859, the telegraph was 17 years old, the first technology in history to run on electricity. 100,000 miles of wire already crossed Europe and North America, carrying news, prices, and love letters as electric pulses. That night, the network went mad. Operators reached for their keys and were thrown back by electric shocks. Telegraph pylons threw visible sparks. In some offices, the chemically treated recording paper ignited at the instrument. Machines chattered out gibberish with no operator touching them. Lines went dead across 2 continents at once. And then the American operators between Boston and Portland tried an experiment that made no sense at all. They disconnected their batteries, completely cut the power, and asked the far end, "How do you receive my writing?" "Better than with the batteries on," came the reply. They worked for 2 hours on no power source anyone could name. The aurora overhead was driving current through the wires, the first time on record a machine ran on the sky. Nobody understood why. The explanation would take decades, and it starts 93 million miles away. The sun is not a steady lamp. It is a ball of plasma wrapped in magnetic field lines that twist, snag, and snap. When they snap, the sun can hurl 1 billion tons of charged material into space, a coronal mass ejection. What Carrington saw was the flash of that snap. What left the sun behind it was a cloud bigger than worlds. The 17-hour crossing meant one thing. This cloud was moving several times faster than anything the sun normally throws. When it struck, it slammed into the Earth's magnetic field and bent it like a sail in a gale. A moving magnetic field creates current in any conductor it sweeps across. That is not a metaphor, that is a generator. For one night, the planet's entire telegraph network became the coil of a generator the size of the Earth. Magnetometers measuring the storm were driven clean off their scales. Modern estimates put its intensity roughly twice any storm since. In 1859, the only wires on Earth were telegraph lines. The damage list was shocks, sparks, and burnt paper. The question is, what happens when the sun does it again, to a civilization made of wire? We have a preview. March 13, 1989. A solar storm hits the Earth, far weaker than Carrington, a fraction of its strength. 90 seconds later, the power grid of Quebec collapsed. 5 transmission lines tripped in seconds. 9,000 megawatts of generation vanished from a system that could not absorb the loss. 6 million people woke to no light and no heat in a Canadian March. The blackout lasted 9 hours. Hydro-Quebec spent $2 billion over 6 years hardening the grid against the next one. And the next Carrington itself has already fired. On July 23, 2012, the sun launched a storm of the same class. It crossed the Earth's orbit through the exact point in space our planet had occupied 9 days earlier. Had it hit, studies for Lloyd's of London priced the damage at $600 billion to $2.6 trillion. Months to replace burnt grid transformers. Satellites degraded. Navigation down. One study projected global crop yields falling by a third. In 1859, the sky's electricity was a curiosity. Today, it is aimed at everything we have built. So, how often does the sun do this? The Norwegian dies, said. Tree rings and ice cores keep the receipts. In the year 774, the Earth absorbed a solar event roughly 10 times the size of Carrington. These are not freak accidents. They are a rhythm, and the sun is near the peak of its cycle right now. In January 2026, it fired the largest radiation storm in over 20 years. The auroras have been drifting south all year. My stowns dots are magical reperticut self-weighed skies. None of these were the big one. The big one is a matter of when. Richard Carrington died at 50, still defending what he had seen decades before anyone understood what it was. We are the first civilization that can see it coming. 17 hours of warning, the same 17 hours Carrington watched begin. And if you want to see what one volcano did to the whole world's transport, that story is already on the channel.